Hey, ninth graders, we are doing our notes today called Absolute Value Inequalities. This is on page 41 in your math binder. So pull out this page of notes and let's start by writing down the definition of absolute value. You've learned about absolute value in elementary school and in the 7th grade. We talked a little bit about it in the 8th grade, but absolute value is a number's distance from zero. A number's distance from zero. So it's how far any given number is from zero. So when it asks what is the absolute value of 12, it's asking how far is 12 from zero. Now, when we count distance, we're always talking about the net distance, the positive distance. So 12 on a number line is 12 spaces away from zero. So we would say 12. Now, this one's saying, what is the absolute value of negative 25? Negative 25 is 25 spaces below zero, but it's still 25 spaces, so we would call that 25. Now, sometimes people try to say like, oh, absolute value means get rid of the negative. Sometimes that's helpful to think about when you're younger, but as we get a little bit further, especially with algebra, we're gonna look at it as being that distance from zero. So even though this used to be a negative 25 and we said it was 25, that's still just saying 25 spaces away from zero. Here's why that's important. What is x if the absolute value of x equals 5? So it's saying what number would fit the description of being 5 spaces from zero? Well, 5 is one of those numbers. So I know that the answer could be x equals 5. That is 5 spaces from zero. What else is 5 spaces away from zero? Negative 5. These are both answers. So I'm going to have you use your pencil to draw little arrows to show that whenever we have absolute value, there are going to be 2 answers. There's going to be one that accounts for the negative spaces from zero, like the negative distance underneath zero, and the other will account for the positive spaces if it were above zero. So let's look at this next problem. Okay, we have what is the x if the absolute value of x minus 2 equals 5. So that means what is a number that when we take 2 away from it, it's now 5 spaces away from zero. So now you're trying to do this algebra in your head and think about positive and negative. So think about that. Can you find a number that when you take 2 away, it's 5 spaces from zero? Well, some of you might be thinking like, oh yeah, I can do that in my head. That's, what is that, 7. When I have 7 and I take 2 from it, it's now 5 spaces from zero. But it gets a little more tricky when you try to do the negative one. Some of you might actually have the negative one in your head, but if not, and if you're also staring at me like I'm crazy with that 7 answer, let's show how to do this. We know that this stuff in here, I want you to circle it, that x minus 2, that is 5 spaces away from zero. So I want you, just like we did last time, to draw 2 arrows here. We are going to talk first about when x minus 2 is positive 5 spaces from zero. Now you know how to solve an equation like this. X minus 2 equals 5. Well, I can undo the subtract 2 by adding 2 on both sides. And what I end up with is x equals 5 plus 2 is 7. That is one of the answers that works. It's the one that some of us were able to do in our head. Now the second equation, x minus 2, this one needs to be accounting for being negative 5 spaces from zero. So I'm going to say that that equals negative 5. I still can add 2 to solve this thing. And then I've got this is 0, so x equals negative 5 plus 2 is negative 3. And if we check that in our head, negative 3 subtract 2 would give us negative 5, which is 5 spaces from zero. So there's a little bit of work that goes into these, but now that we know how to solve them, we can do more with these absolute value inequalities. If you're wondering why we do this, well, this is a big part of the 9th grade core, and we are going to be testing on it at the end of the year. This shows up on ACT testing, so let's try to get this now in an inequality, a graph, and interval notation, since we know how to do those things. This first one, notice how I went from equaling and now I have an inequality. So we've got absolute value of x is less than 3. So what does that mean? it means the distance from 0 is less than 3. Okay, so let's start on the graph. I'm going to put 0 in the center, and I want you to do the same. And then I'm going to graph 1, 2, 3, and -1, -2, -3. Okay, remember, I want the distance from 0 to be lower than 3. It needs to be less than 3 spaces from 0. So what sort of things fit that description? Is 0 less than 3 spaces from 0? Yeah, it is. So it works here. 1 is less than 3 spaces from 0. 2 is lower than 3 spaces from 0. Or I keep saying from 0, from 3. Hold on, I think I just confused myself in my own head talking about 0 and 3. But let's start with an open circle at 3, because I know that we're comparing to 3. So if the absolute value of x is less than 3, my distance from 0 is less than 3, and I'm going to shade everything lower than that 3. Now I'm actually going to stop at 0, because then I'm going to look at the other side to see how it works with -3. So remember, I'm less than 3 spaces from 0. So it's going to be closer to 0 than -3. So all of this space in between satisfies the distance being less than 3 spaces from 0. Everything in this shaded region is closer than 3 spaces from 0. So the inequality for that, well, this is an and statement, but it's simpler, in my opinion, to write it like this. Usually when we're looking at a graph, we can say -3 with x in the middle, and then +3 right there. And we fill it in with our less thans. Now, I wrote that kind of small here because when we're given the first inequality, we don't often jump right to this. So let me show you how we write this as well without having it be one solid long compound inequality. You have absolute value of x is less than 3. One of your inequalities is going to look like this. X is less than 3. It matches what you were given, x being less than 3. Then, you see how we shaded that space in between? We would write and, because this is an and statement. Then, we also need to talk about x going higher. The shading went higher than -3. So we would say x is greater than -3. So we wrote down the original thing here, but then when we changed it to a -3, we had to flip the inequality in the middle. So x is less than 3 and x is greater than -3. My interval notation here for this graph would begin at -3 with an open parenthesis because there's a not filled in circle, all the way up to +3 with an open parenthesis because the circle is not filled in. Okay, let's go to this next part. On the next one, the absolute value of x is greater than 3. So I'm going to go to my graph again. I'll put 0 in the center, 1, 2, 3, and -1, -2, -3. So this time I'm comparing, it's going to be a greater distance than 3 from 0. So if I put an open circle here, because it does not say to equal 3, I need to go greater than 3 spaces away. So I'm going to point my arrow away from 0. Then I also have to do the same thing at -3 because it's greater than 3 spaces from 0, and that's 1, 2, 3. We'd go greater in the negative direction. My interval notation, -∞ to -3, open parenthesis, or 3 to infinity, open parenthesis. All right, lastly, let's talk about our inequality. The first part of the inequality we shaded below -3. The second part of the inequality we shaded higher than +3. So higher than +3 means x is greater than 3. That one looks just like the original inequality that we were given. And then because they both point opposite directions, I would write or, and the other inequality is lower than -3. So I'd have x is lower than -3. All right, so this goes back to that and or statement. We're going to see one sort of compound inequality. And as always, we'll write some stuff in the question/notes to help us with this. So when we had a less than symbol here, less than symbols always give us an and statement. So less than is going to be an and statement. If you have a greater than symbol, it's an or statement. Now, that also includes equal to. So if you've got a less than or equal to, that would also be and. Greater than or equal to would be an or statement. So anytime there's a less than included, it's an and statement. Anytime there's a greater than included, it's an or statement. So we're going to talk about this word problem, and it says, did you know a 20-ounce box of cereal might not actually be 20 ounces? Can you believe that? The world's trying to rip you off. They call this tolerance, meaning there is a certain range a box can weigh and still be labeled as 20 ounces. Suppose that a certain cereal brand has a tolerance of 1.5 ounces. You are going to solve the following absolute value inequality to determine how much a box of this cereal can actually weigh to keep the 20-ounce label. So we're starting with this absolute value inequality. X minus 20, absolute value, is less than or equal to 1.5. I want you to begin by taking the stuff in the center and circle it with your pencil. Now I am going to have two inequalities that come from that. So I'm going to draw an arrow, and I'm going to draw an arrow over here because I need some space. Is this less than with an and symbol or greater than with an or symbol? Well, if we look, it's got the equal to, but it is less than or equal to. So this is going to be an and statement. And on each of these problems, you've got two answers. Let's talk about those two answers. The first answer is just your regular old answer. Your second answer is going to be negative and reversed symbol before solving. So we're going to do the negative and we're going to reverse the symbol before we solve them. So let's start with the first regular looking answer. This one, we take that x minus 20. I leave the absolute values off, and I'm going to keep my less than or equal to 1.5. Now remember, it had the less than symbol, so I'm going to write and. Then for my second inequality, I still have this x minus 20, but instead of less than or equal to 1.5, this one's going to be greater than or equal to negative 1.5. All right, now I solve both of these things. So for this first one, I can add 20, and I get x is less than or equal to 21.5. Don't forget to rewrite the word and. Over here, I add 20, and I get x is greater than or equal, negative 1.5 plus 20 is positive 18.5. Okay, so you know that your weight is going to be lower than 21.5, but greater than 18.5. So really that's saying that it is 18.5 with your cereal weight in the middle and 21.5 up above. That is going to be the tolerance range that you've got there. And judging by the fact that people are usually trying to rip you off, they're probably gonna fill the cereal lower. I would actually venture to guess that often they try to get as close to 18.5 as possible. But maybe not, maybe like Malto-Meal and Cheerios are really kind people inside their hearts. I just don't think they are. All right, let's look at the next one. Solve each absolute value inequality. Graph the solution set. Write the solution as a compound inequality and in interval notation. So we are going to start on this first one. And remember, we have two ways to write these answers. The first way is x greater than or equal to 6.5. I copy it down exactly the way that it was written. I don't know why I'm writing this above the word inequality. Now, since that's a greater than symbol, that is going to get the word or. And then the second one, I still have the x. I change that to a negative 6.5 because I'm doing the negative reverse symbol. And that changes to a less than or equal for this negative 6.5. So when I put this on my graph, I've got 0, 1, 2, 3, 4, 5, 6, 7, negative 1, 2, 3, 4, 5, 6, 7. And my graph is going to go greater than 6.5. So I put my dot, solid circle at 6.5, and I'll shade above. Then I'm going to go lower than or equal to negative 6.5. So I put a solid circle and I'm shading below. My interval notation for that is saying from negative infinity, comma, to negative 6.5, or 6.5 to infinity. And remember, infinity always has open parentheses. All right, let's go to problem number 5. I don't know why I said 5. It's probably because it has a 5 in it. I'm actually going to have you try problem number 2, and we will check it in just a second. So do your best on problem number 2. We will check it together. It shouldn't take you much more than like 3 minutes. All right, let's go over problem number 2. We've got x less than 5. We know that that means it's going to be an and statement. So the first part of my inequality is going to match exactly what I was given. It'll say x is less than 5. Then I'm going to write the word and, because this is an and statement, it's going to point inward because they're both going to be closer to 0 than 5 and negative 5. And then I will have x compared to negative 5, but instead of the less than symbol, I'm going to reverse it. I'm going to make it a greater than symbol. So I'll have 0 in the center, and then I have 1, 2, 3, 4, 5, and negative 1, 2, 3, 4, negative 5. All right, these do not have equals on them, so they are not going to be filled in circles. These ones are going to be open circles. So I've got positive 5 with an open circle, negative 5 with an open circle, and remember when it's an and statement, you will shade in between them. So my interval notation is going to be from negative 5 to positive 5 with open parentheses because they are both open circles. All right, let's go to problem number 3. Problems like this, be very careful on a problem like this. A mistake that I often see is people try to say x plus 3 is less than or equal to 12 and x plus 3 is greater than or equal to negative 12. I wrote that in pencil because that is wrong. That is not what you do here. You cannot do that because the absolute value is not isolated yet. You need to get the absolute value alone. We've got to get rid of that 3 first. So I'm going to do my power erasing here. We need to get rid of that 3, and to do so, I'll subtract 3 from both sides of this inequality. So I still have the absolute value of x, and this is still a less than or equal, but 12 minus 3 is 9. So now my inequality, x is less than or equal to 9, and that is an and statement because we've got the less than symbol, so I'll write and x is greater than or equal to negative 9. When I put that on my number line, I've got 0. I'm going to count by 3s because I don't want to do 9 tick marks. I'm going to say 3, 6, 9. And in the other direction, negative 3, negative 6, negative 9. Remember, this is an and statement. Both of these have equal to's on them, so they will be filled in circles at negative 9 and at positive 9. And I can shade everything in the middle. My interval notation will be from negative 9 to positive 9. All right, try problem number 4. I know, there's a decimal. You'll make it. It's just like problem number 1 with that decimal. Push pause, do your best. I'll go over it in like a second. Okay, on number 4, I've got to undo this that minus 1 by adding 1 on both sides. I have the absolute value of x is greater than 2.5 plus 1 is 3.5. When I write that out, x is greater than 3.5. And remember, a greater than symbol is an or statement. So I write or x is less than negative 3.5. So I will put 0 in the center, 1, 2, 3, 4. -1, -2, -3, -4. 3.5, positive 3.5 would be halfway between 3 and 4, and that is greater than there. Less than -3.5 would be between -3 and -4, and we're going less than, we shade below. My interval notation would be -infinity to -3.5, or 3.5 to infinity. All right, that is enough of this for one lesson. We are going to do page 42 for your next page of notes. That'll be tomorrow. So today's practice will, I think today's practice includes stuff like this. I don't know, you'll see in just a second. So let me know if you still have any questions on this stuff. Good luck, my ninth graders.